when you were there? Okay, she's the long-time lab technician and teaches labs, but I would imagine.
No, when I was out there was no lab technician.
Okay.
Teachers
Well, you were.
the instructors were
You would not have been in. You'd been in
All
Woods Hall or
right.
some other building than our current
Hello. I can't see. I'm getting old. You all laugh. Why are you laughing? Okay. All right. So hi, welcome to Lunch and Learn. I'm Dr. Jennifer Vanette. I'm Outreach Coordinator here at the Castle Museum. So it's my pleasure to host our Lunch and Learn events. A few housekeeping announcements before we begin. There is a restroom just out that back door. If you so need that, that is very conveniently located. We do ask you to please silence your phones. It helps us if those don't ring during the talks. And then, despite that sounding very formal, we do keep it casual. So if you need a refill on that coffee or another brownie, feel free to help yourself. There's a refreshment table in the back. Did I remember everything, Sylvia? Is that all my housekeeping?
upcoming.
Thank you. See, we got some regulars that keep me honest. Okay, so, oh, I should tell you. Oh, see, I did miss something. The next Lunch and Learn. Okay, so the next Lunch and Learn, remember we do these every second and fourth Tuesdays. So our next one is May 12th, and we will have Philip Ellison, who is a lawyer. And he has just argued a case before the Supreme Court of the United States. So he is going to come and share about that experience and talk about local issues before the court. So that should be very interesting. All right, today we have our next in our America 250 series where we're looking at the power of place in different ways. And so today we're going to look at the environment. And we have Dr. David Karpovich here with us. He is an analytical environmental chemist. Is that correct? Okay, good job. I mean, you never know. The internet lies sometimes, people. I don't know if you know this. Okay. All right. Exactly. Everything on the internet you read is true, quoted to Abraham Lincoln. So, yes, right? Get it? Get it? Abraham Lincoln wasn't alive during, I mean, it wasn't that funny, but it deserved a chuckle. Okay, all right, sorry, I'm really like messing up your intro. All right, let's go back. Sorry, he's never gonna compact people at this rate. All right, okay, regroup, we're serious here. All right, so we are pleased to have Dr. David Karpovich. He is the H.H. Dow Endowed Professor in the Department of Chemistry at SVSU. He is also the director of the Saginaw Bay Environmental Science Institute, which provides hands-on research experiences for undergrads from both SVSU and Delta College. So that's really cool. So without further ado and like silliness, I'm gonna have Dr. Karpovich take it away. Thank you for being here.
Thank you, Jennifer. I'm happy to be here today. Thank you for inviting me. And I'll tell you a little bit about myself. I'm pretty much a lifelong resident of this area. I grew up in Carroll, out in the Thumb. So I'm a Thumber. And went to Saginaw Valley State University for my bachelor's degree in chemistry, and then moved on to Michigan State from there. And I spent 2 years out in the state of Washington at a national lab, really because I wanted to be able to come back and teach at Saginaw Valley because they had a big influence on me, and I just liked what they did with students and for students, so I had to go somewhere and get some new ideas before they'd consider hiring me. So that's why I went out there. So that's 2 years I haven't lived there, and quoting my uncle, when people ask me if I've lived my entire life in this region, I say almost, but not yet, because I've got a few years to go. So it's not over yet. So I'm happy to be here, and what I work on for the topics I teach and research that I do is because I just love the area. I grew up on a farm, and that actually plays a role in the things I research. And so, without any more, boring you of those things, we'll get into this. And so I'm going to talk about some Saginaw River things, because that's what I told was what kind of sparked this. Some newspaper articles, it sounds like you were reading about issues that came up in the Saginaw River maybe back in the 70s and 80s. So I put this title together. It's not the end all of everything. I have to tell my students and remind them this, and they laugh because they're not thinking this, but I don't know everything. But I'll tell you what some things from my perspective. And so we're going to go through a few issues and programs that address the issues, and they're probably the things that come to my mind, partly because I work on them, partly because they are the big things. There's probably some other issues, and if you have questions about them, I'm all ears. We can talk about them. I'll go through the environmental things. I'll point out some things that we're doing, my students and my colleagues and I are doing to address some of the issues in the environment in our role at a university. And at the end, I have a few things to tell you about our group at the university, the Saginaw Bay Environmental Science Institute. So, so hopefully that's all interesting to you. There are a lot of words on the slides. They're meant more for me than you, so just let me guide you through this. So since it's, the importance of place, the power of place, what I heard, let's get some context of where we are. We're in the Great Lakes region, and that's 84% of the United States freshwater, 21% of the world's freshwater. That's huge. The shoreline touches 8 states and 1 province. If we look out a little bit to the Great Lakes Basin, so that's all the water that drains into the Great Lakes watershed, if you will. It's a home to 30 million people. Lots of agriculture, 25% of Canadian agricultural production, 7% of U.S., and 8 states and then 2 provinces, because while Quebec does not border the Great Lakes, some of its land area does drain in. So that adds 1 more province there. Okay, so, well, we're in there, of course, and you know where we are. Yes, sir.
Your 30 million people currently does not include Chicago?
Chicago is just outside. Yeah.
Confirming
Yeah.
my interpretation of your data.
Correct. Yep. So yeah, it's very interesting because the Great Lakes watershed comes so very close to the lake. The boundary is so close to the lake on that lower Lake Michigan part. So if you follow issues and things, they're concerned about fish getting in from Chicago into our area, and there's that dividing line. So yeah, there are some communities, towns in that area that part of the town's draining in.
Their drain water does not go into the Great Lakes, but they get their drinking water from the Great Lakes.
Yes, in many cases, yes. So, we're right here. Everybody uses the hand to, and I do this when I go to conferences outside of the state. People laugh at me because I like to use the hand to describe where we are. And so this is a picture of the Saginaw Bay watershed boundaries. And the color coding in there is land use, where the yellow is agricultural. The red dots you see in there are urban centers. And so the watershed, 8,700 square miles, all are parts of 22 counties, 7,000 miles of rivers and streams, and I'll mention almost 2,000 miles are artificial ditches, a lot of those in the thumb, and home to over 1.4 million people. And I could go on. It's home to millions of birds, migrating birds stop over in our wetlands, lots of important fish and wildlife, and so it's a very important region. I tell my students when they're here at Saginaw Valley in this region, trudging through winter and dreaming of warmer places, and we get biology students that want to study the Everglades, the Amazon rainforest, or the Great Barrier Reef. I tell them that the Saginaw Bay watershed and Saginaw Bay are just as important to this region and just as important to the Great Lakes and the world as those ecosystems are where they are. This is a world-class ecosystem. I've talked with people about that, scientists from different places, and they all agree. Yes, sir.
Yeah, weird watershed. Define that.
Thank you for asking that. The watershed would be the land area over which all that water drains into a common basin. So the Saginaw Bay watershed, on these boundaries, all the water from that boundary in would make its way through creeks and streams and rivers to Saginaw Bay.
Any water could drain to the area of Saginaw River for that?
Saginaw River is, yes. Pardon me?
More than that though.
Oh, yeah.
At least two other rivers
Oh, yeah.
that are included in
Absolutely. So the Saginaw River watershed is a subset of this. And then there's, and actually that, if you see this boundary right here, that would be the Saginaw River watershed because all those streams drain to the Saginaw River. Actually this as well. These areas have some direct streams. So the Pinnebog River, the Pigeon River, the Seaboing River, which you can't see, the Calcallan, there's Pine, Saguenay, Rifle, All Gray, those go direct into the bay. So they're part of the Saginaw Bay watershed, but not the Saginaw River watershed. So, yeah. I'm going to start talking about issues. And I want to say before I get into the issues that we can get bogged down in the issues. Don't forget, there's a lot of good things. There's good boating. There's good fishing. There's good drinking water in many, all around here. There are exceptions, of course. But there's a lot of good things to say about this region and a lot of qualities. But we're going to dive into the problems. So don't get depressed. Okay, don't read all the words. I just want to say something about the Great Lakes Water Quality Agreement. That's the driving force behind a lot of what's going on to address issues that I'm going to talk about. It's a framework for binational cooperative action to restore, protect, and enhance the water quality. So binational, meaning us and Canada, of course. And Canada has an interest in Saginaw and Saginaw Bay because it's part of Lake Huron, and Lake Huron is there's a binational group that helps manage the Lake Huron resource. And I actually spoke to that group the other day. You're going to see some of the same data here. So the original Great Lakes Water Quality Agreement was signed in 1972. It's been amended several more times. In 72, they were focused on point source pollution, specifically phosphorus. We'll talk about that. 78, they brought in toxic pollutants, which the Clean Water Act in 72 also had addressed. In 87, they established 43 areas of concern and around the Great Lakes. And then again in 2012, they added in climate change concerns, and also they divided it up into annexes. There are 10, there might be more annexes. I forget details. But Annex 4 is on nutrients, including non-point source pollution. So I'll explain what that is. And I promise I'll get to some of the things I looked at in the news article that you had, that I said you had looked at, but this is going to cover some of that. So the areas of concern. This picture is from the EPA's website, and you can find all this information if you Google EPA AOC, stands for Area of Concern. EPA AOC, you'll find the first two hits. The one will be the EPA's website on the Area of Concern program. The next hit will be EGLE, State Department of Environment, Great Lakes and Energy's website, also on the areas of concern. They work cooperatively together to address these. And boy, that image is kind of cloudy, but what you see in these markings are U.S. areas of concern in the blue marks. The red are the Canadian areas of concern. These are areas where there's issues that are worse than they should be, maybe worse than average, notable things that are worse than what maybe other similar areas would have. And so I'll get more specific on that in the next slide. I like to point out to my students and to everybody that yes, Canada has environmental problems too, as do we. There are environmental problems up north in the Upper Peninsula where we think things are pristine, and we're in Saginaw, and this obviously we have some problems because of the industrial history. People think that let's get out of Saginaw, but there's problems all over. mining can cause problems. Wastewater treatment plants have historically caused some problems, and hidden industries here and there. So, and there's some things actually left over from the logging industry. There's one area of concern over in Wisconsin where the issue was buried sawdust that was under the harbor finally started to rot and caused a depression and dissolved oxygen in the water. So really, fascinating things, but of course issues and problems. Some of these things, as they get cleaned up, get delisted or removed. So more words, don't go through these, but an area of concern has one or more severe beneficial use impairment, BUI. And a beneficial use impairment would be something like number 5, beach closings. The beaches have to be closed because of either bacteria or harmful algal blooms, and it's worse than normal, worse than other places, so they list it. Restrictions on dredging activities. If you have to dredge the river, as you do for ships coming in, are there restrictions because of contamination? If so, that gets listed. So there's all these. We're going to go through these in maybe some clumps moving ahead here. More focused on the Saginaw River and Bay. So we are in an area of concern called the Saginaw River and Bay Area of Concern. They're very specific about the designation. The picture here shows the boundaries. So it's all of Saginaw Bay through the Outer Bay and the Saginaw River. Areas outside of the boundary, like out in the thumb or west of here, are not part of the area of concern, but if an issue out here is contributing to a beneficial use impairment, the program may help fund work to solve the issues out here. So, and it's just a matter of the EPA and where they want to draw the lines, and where they can't work out here, other agencies like Eagle take over and they pick up the slack and kind of work in conjunction. Yes, sir.
Back on the map, says 2 places like a recover, remember that? The 2, like a yellow over there? What does that mean?
So this map here, areas in recovery. So areas that are in recovery are kind of in between fully being listed, and when they fully recover, they're delisted. So I actually don't know at what point they move into areas of recovery. I'm familiar with going from listed to delisted, and that's when all of the beneficial use impairments have been removed. So areas in recovery would be somewhere in between there. That's a good question. I've not focused on those.
They're bad or they're better?
Yeah. But to your point a little bit further, there are several delisted areas. So we have one here, Oswego River, and Canada has, there's some stars here, some delisted areas of concern. And so we're striving to get there with Saginaw. We have a long way to go. There were 14 beneficial use impairments. We had originally 12 of them. The ones we didn't have were fish tumors. That's nice to know. And added cost to agriculture or industry. Doesn't mean those things don't occur. It just means they're not occurring at a high level that are notable. We've had 3 of these beneficial use impairments that have been delisted. And that's loss of fish and wildlife habitat. So they've made improvements with some reefs out in Saginaw Bay. They've buried rocks for fish spawning. They've made some improvements on several dams around the area, like Frankenmuth has a fish ladder now, and some wetland improvements. So that allowed them to remove or to delist that. Drinking water restrictions or taste and odor problems, that was removed. Those were taste and odor problems because of a water quality condition. You probably remember the Flint water crisis. That's not part of this program. So that wouldn't, it's outside of the AOC boundaries, and that actually wasn't what it was listed for to begin with. So don't be confused. This doesn't mean there weren't problems in our area. They're just not covered by the program. Tainting of fish and wildlife flavor, that was also due to some water quality condition just causing a flavor issue. Some of these beneficial use impairments weren't listed for scientific reasons. They were listed because of perceptions in some cases. Yes, sir.
I assume that was maybe a multi-million-dollar cleanup of the accident in the Wassee River would have been an Cost stay straight.
Yeah, probably, but it is an added cost, but it's not part of this program. But I will cover that in here. It's another program. So yeah, we'll get to that as well. I thought I'd lump these a little bit, and we'll start with the BUIs in red that are related to industrial chemical pollution. And so I've listed a few big ones here. PCBs, which are were used everywhere. They're still used in some places. They're not sold and manufactured now for those uses, but there's leftover PCBs. Mercury, which is everywhere because in part coal burning, and not just our coal burning here. We get mercury from coal that's burned elsewhere, like Chicago. The wind carries it and deposits it. DDT, which is an insecticide, very effective insecticide. It reportedly saved many from malaria in World War II. Soldiers were dusted with DDT, but they found out a little later that it's toxic. These things are carcinogenic, they found out later. DDT has that specific thing where one of its breakdown compounds, DDE, causes eggshell thinning. So as chemicals like this, like DDT or DDE, enter the food chain, they accumulate in the fat, and big fish eat little fish, bigger fish eat those fish. Birds like raptors come and take the fish, and every time you go up a level in the food chain, those contaminants are amplified. Rule of thumb is about tenfold. But predators receive a higher dose of the contaminants than the organism that feeds on it or that accumulates it first. So that's just a little backstory there. This was an issue in St. Louis, Michigan. There was a Michigan chemical company, actually a burial of a waste site there that is called a Superfund site. We'll get to that. These were used as cooling oils and transformers and lots of parts in industry that needed cooling, and mercury again from coal. So those BUIs related to fish and wildlife consumption, fish and wildlife populations, dredging activity restrictions, deformities, reproduction problems, and degradation of benthos, the bottomlands, are all affected by this. So I'm going to step outside the area of concern program because, as you mentioned, dioxin, there is another type of a site, Superfund site, Tittabawassee River, Saginaw River, and Bay Superfund site. It's one big Superfund site that encompasses Saginaw Bay, Saginaw River, and the Tittabawassee River because of historical contamination of dioxins. Some people are surprised to learn that dioxins were never manufactured on purpose. They were a byproduct of other chemical manufacturing that involved chlorinated organic compounds. The conditions were right and trace level dioxins were made. It turns out that this has the label as being the most toxic compound ever discovered. I would say produced, artificially produced. There's evidence that it's also naturally occurring if there's fire and chlorine together. But so very interesting. That's just one example of the dioxins, and also furans that would be part of that contaminated site, the Superfund site. I don't do laws really well. I always have to look this stuff up, but it's covered under CERCLA, the Comprehensive Environmental Response Compensation and Liability Act of 1980. I always have to look it up, but just a little bit of a backstory there. But Superfund is its own program. The Area of Concern program doesn't work with this, but they do communicate. Laws are funny, agencies are funny, they'll have boundaries, but they are working together quite well. Let me back up here. You could Google that. You could find out where this is. There are several areas of the river and segments, and I think they're out to like segment 7, kind of rounding the Tittabawassee to the Saginaw River in terms of their cleanup activities, would involve removal in some cases, stabilization in other cases. Did you have a question?
Yeah. You know what they actually start making the dioxin? They had the CDs later on, but actually when we actually started creating.
there was the first real notice of it was when they were making Agent Orange for Vietnam, and a combination of 2,4-D and 2,4,5-T, those two pesticides, not Dow Chemical, but another company had some conditions wrong in their synthesis that promoted the side reaction of dioxin to be formed. Interestingly, when that problem came about, when people noticed it, it was because a chemist at Dow developed a method to detect it. We wouldn't know about it if Dow hadn't had their analytical people setting this up. So they developed the method. His name is Warren Crummett. I've read his book. I met him. He developed a method that could detect this at a part per trillion level, and then that method turns around to find dioxins at trace levels in the Tittabawassee River at hundreds of parts per trillion, very, very small levels. But that method discovered this. And so then they discovered with that method, which was developed in the early 70s, they started to develop, started to find the contamination. So I don't know when it was produced as a byproduct in the plant. Like I said, they never manufactured it as a product. It was a byproduct. I don't know when it first would have gotten there.
I remember it graduated in 72, you know. But I remember driving to Alma and St. Louis. They said,
Well,
don't go there like that.
well, Alma, St. Louis, that's the DDT site. The Velsicol Chemical Company. Also, they produce PBBs. So if you've lived in Michigan as long as I have or longer, you remember the PBB scare where Velsicol Chemical or Michigan Chemical had a product called Firemaster, which was cattle feed, or which was a fire retardant, excuse me, and Feedmaster, which was cattle feed supplement. The bags were blue and white. They mixed up the bags. And so polybrominated biphenyls, which would be just like this but with bromines, were fed to cattle. And cattle started getting sick. They figured this out. And I don't have that in here because it wasn't part of the Saginaw River thing, but I teach my students about it. They ended up killing cattle and burying them up in Mayo near Mount Tom. If you drive into Mayo on M33, you see the big hill. That's Mount Tom. Not far from there is the burial. My grandfather was there while they were doing that, and he visited the site afterwards. He was a dairy farmer, and actually one of the cousins on the family, big, huge family. I got 9, including my mom, 8 aunts and uncles. But so lots of people. But one of our family's herds had to be destroyed, and farmers were sick over it because they get attached to their cattle, right? You have a question?
So, as you brought up Alma, that area, there's a separate Superfund site in St. Louis, right?
Yep, that's right here.
And that is the Saginaw River Basin, right?
It is the Saginaw River Basin, yes.
Yeah.
But it is not part of the Saginaw River and Bay Area of Concern.
Well,
Yeah.
it's still
But-
an active Superfund site, right?
But Superfund is not part of the Saginaw River and Bay Area of Concern. Yeah, so the area of concern addresses the beneficial use impairments. Superfund addresses the actual contaminants. To the extent that area of concerns impairments depend upon Superfund cleanup, there has to be cooperation. So I'm actually part of the Public Advisory Council for the Area of Concern program, and we are working with the Superfund site managers and also the Army Corps of Engineer, who they have a separate job of monitoring the riverbed for dredging. That's not part of the Area of Concern program, but if we're going to work on delisting one of the beneficial use impairments that depends on their contamination, we need to know when they're cleaning it up. So we wouldn't recommend delisting until those issues are corrected. So they're separate programs. Doesn't mean we're not worried about it because it's not part of our program. So I hope I made that distinction correctly. So this, you can go, there's these little yellow crosses around here. Those are areas in this region that are brownfields. Potentially contaminated sites because of their history. They're not necessarily contaminated. Some of them are. Some of them haven't been tested yet, but they're potentially contaminated sites And the issue is, can they be redeveloped or not? If that's the case, they could be in the brownfield program. If you search for CIMC EPA, so cleanups in my community, EPA, the first hit will get you this tool that can zoom in on these maps, and it's pretty interesting to look at. Yes?
Are you going to cover where the stuff they're cleaning up goes to when it's cleaned up?
We can talk about it. I don't have a picture of it, but yeah.
Thank you.
So, yeah, in fact, this is a good time to talk about that because I'm going to move on to something different. When they remove contaminated sediment, for instance, like dredging, which happens regularly, I've looked at the list of, they go through and they test all the, several sites in the Saginaw River, pull samples, test it for metals, test it for dioxins, PCBs, DDT, and if the dredgings are clean, they have lots of freedom on where to put them. They could put them on the side of the river bank. They could take them to a landfill for that purpose. If they're contaminated, if it's bad stuff, there are only certain landfills that will take it, and it costs money, or they can put it on the combined disposal facility island, which is just outside. You can't quite see it, but it's if you go out to the mouth of the river, there's that island out there. And so that was constructed in the 70s. It had a 10-year lifespan, and it keeps getting extended. And it's a contaminated island, surrounded with clay and things like that. I climbed up there once. We have a little boat back when I was early in my job at Saginaw Valley. We boated out there, and we kind of climbed up and looked, and it's just doesn't look like you think it would look. It just looks like a dump, piles of dirt. But yeah, they have to, that's the added expense for dredging, is to deal with the contamination in the sediments that you dig up. Yeah, where it goes. Okay. So those are some issues that make the big headlines. The dioxin, the DDT, the dredgings from the Saginaw River, and all these sites in here that aren't part of the Tittabawassee Saginaw Superfund site, these other brownfields. If you know Saginaw, you know of all the factories that have been through here, all the metal shops, all the metal cleaning, but even dry cleaners end up on this list because of the tetrachloroethylene that they use for dry cleaning. So paint shops, if battery shops, chrome plating places are on this list. We've had a long history of industrial activity, and potentially those are contaminated sites. Gas stations that have buried tanks could end up on this list. So lots to be concerned about, lots to watch. I don't get too worried about a lot of it. I mean, I am. I mean, it's part of my job. It's part of what we do. We care about the environment. But I don't go through the world worried about touching the next thing because we just have to live here. And there are some smart people keeping an eye on these things and keeping an eye on the people who should be keeping an eye on them, because some people don't. Some people just want to, But let's talk about some other things. We're going to get close to what I saw in your newspaper article. These in red are related to nutrient pollution. And by nutrients, I mean things that be in fertilizers. Nitrogen in the form of nitrate, phosphorus in the form of phosphate, and what it leads to is these algae growth issues and a process called eutrophication. So here's another picture. You've probably seen water that turns green because of algae. And I'll tell you what we talked about before, those contaminants. If I knew mercury was in the water or in the fish, I'm not going to eat the fish. I'm not going to swim in the water. Or PCBs, if I know it's really contaminated, I'll stay out because it's dangerous to me. Nitrogen and phosphorus, I don't care. Have the highest levels of phosphorus in the world. I'll go swimming in it. I don't care. Doesn't hurt me. I'll drink phosphate because it's in here. Most drinking water has a few parts per million of phosphate as part of the treatment process. And it's added to your city drinking water to prevent corrosion of pipes. So it's not the chemical itself, it's the expression, what the environment does with that chemical. And what the environment does is it takes nitrogen and phosphorus and sunlight and makes algae. And algae, when it grows, photosynthesizes, makes oxygen, and fish love it. And then when it dies, it consumes the oxygen because it rots, and so you get these high oxygen levels in the daytime, and it drops down really low at night when the algae respire. When it rots, it gets even worse, and fish get trapped. If you've been out to the beaches on Saginaw Bay, some years it's bad, some years it's not even there, but there's muck that washes up. Most of the time that's algae from the bay that's just started to rot, and it's in different levels of decay. Yes?
Yeah, I see people fishing the Saginaw River all the time.
Mhm.
They're safe.
Yeah, there's fish consumption guidelines. So this is a world-class walleye fishery, and the fishing guidelines, and I know the people at Michigan Department of the Health and Human Services labs in Lansing that measure the fish, and they determine certain sizes of fish are safer because if they're big, they've been predators much longer than if they're smaller. So super large fish you wouldn't want to eat. The smaller fish, trim the fat because most of these things accumulate into the fat. They figure out what safe levels are. If people are pregnant or have certain health issues, they might be recommended to eat less, but there are published fish guidelines. But those are all because of the chemical contaminants that we talked about before. This doesn't affect it at all, just to be clear. I know your question may not be about this, but
I know.
yeah. So these algae things, these are more about habitat that's appropriate for healthy fish. So if you have this condition going on, you'll end up having degraded fish communities because algae-infested water ends up having not very good oxygen levels, for one. So the quick answer is let's cut down on the nutrients going into the water. I'll tell you how that's being done. There's a complication. One is from invasive species. The zebra mussels, you've heard of them. They're part of this group called the dry-cynid mussels. They changed what was happening to phosphorus in the bay, and they altered the food chain, and phosphorus is actually part of the food chain. It has to go up the food chain and get shipped out to Lake Huron. They stopped it or really complicated it. And then Lake Huron, when I talk to scientists who are fisheries biologists in Lake Huron, and I say, well, we're working on the nutrient problem in Saginaw Bay. We need to have less going into Saginaw Bay. And they say, no, please don't. We need more phosphorus out in Lake Huron, and we're depending on Saginaw Bay to give it to us. Because their fish need the phosphorus. That's what carries energy up the food chain. So the lake trout can't thrive without more phosphorus. And so what was supposed to happen, what traditionally would happen is phosphorus would come in off the watershed, get transported through the rivers and lakes, and start going up the food chain through the plankton, through the algae, the plankton, the little fish, the bigger fish, and migrate on out of the bay to Lake Huron, and that cycle would keep on going, and phosphorus would leave. The zebra mussels came in, filter fed so effectively, they took all the plankton out. They outcompeted the native mussels, but they filter fed, so then the little fish didn't have anything to eat. They broke the food chain. They consume all the phosphorus that's in that plankton that should have been exported out, and they excrete it as plant-available soluble phosphorus. You may have heard they cleared up the water. People were excited. Now we have a clear bay. Most scientists agree it's not supposed to be clear because it's shallow. The other ingredient is sunlight. So when they cleared up the water, sunlight got in, could reach the bottom where the algae starts to grow. The phosphorus was there, ready to feed it. And so the algae would grow, and they call this the nearshore shunt for phosphorus. It keeps it there rather than exporting it out. So invasive species really complicated it. I'm getting a little ahead of my slides, but so I've already covered half the slide, but historically, the BUIs that led to algae were because of wastewater treatment issues. So wastewater treatment plants used to use phosphates a lot to take out metals, to take out hard water ions, to precipitate solids, and their goal was in reducing the waste that was in the water so they could put clean water out. They weren't concerned about the phosphorus. People didn't think it was an issue. The Great Lakes Water Quality Agreement in 1972 focused on point sources of several things, but including phosphorus. and they encouraged wastewater treatment plant upgrades, which happened in the 80s. When they happened, their output for phosphorus dropped. Some laws in the middle of there too made it so they had to get permits to release phosphorus. So now wastewater treatment plant can let out concentrations of about 2 parts per million phosphorus, but it also depends on how much they're sending out in terms of volume of water. So there's a load of phosphorus that they can put out. That's what the term is called. And it's permitted, but it's strongly regulated. And so phosphorus decreased and chlorophyll, which is a measure of algae in the bay, decreased significantly in the 90s, or in the 80s, excuse me. Then the zebra mussels came in 1991. They altered the phosphorus food chain thing that I just described, and eutrophication, the algae started to worsen again. All because of clear water and the food chain interruption. So that has kind of, it hasn't mitigated. They're still there, but they've kind of, there's a few predators of the zebra mussels that have kind of kept them a little bit more in check. But then, so we can't do a lot about it, but we've turned attention to non-point sources, which were spelled out in the 2012 Water Quality Agreement, but we started working on them before that. So point sources are when you have pollution coming out of a pipe, and you can say that's the spot. So wastewater treatment plants are point sources. There's lists of them. You can look up what their permits are. Flint has several. We have one here in Saginaw. There's a couple in Bay City. They're discharging to the water. Non-point source pollution, you don't know exactly where it's coming from. You know regions, because rainwater comes down, washes across the landscape, washes into the rivers, and so it's a non-point source. It's an area, so to speak. So it's harder to pinpoint because you can't pinpoint it. So here I'm going to get into a little bit of what we're doing at Saginaw Valley, and I'm going to check the time because we're getting there. We are tracking the non-point source pollution. My students do this as part of the Saginaw Bay Monitoring Consortium, and these are our partners project. So we're not doing this in a vacuum. We have Michigan Department of Ag, Michigan Department of Eagle, NOAA, Great Lakes Lab, U.S. Geological Survey. EPA funds it. If you want to learn more about this project, if you Google SVSU and SBMC, you'll find that. You'll find an informational page that has reports, even a summary paper on this of what we're doing to address non-point source nutrient pollution. And you can't see all of this, but these are the things we're measuring. A couple phosphorus types, a few nitrogen types. And here's the Saginaw Bay watershed, and these green stars are the sampling sites where we're collecting water samples from the rivers. USGS is measuring water flow. We get concentration, they give us flow, we calculate how much phosphorus gets delivered. And those sites are selected carefully so we get certain regions in the watershed. And so what we get out of this are some things. I just showed this to the Lake Huron Management Group, Canadian and United States officials from like EPA, Environment Canada, Eagle, Ontario Ministry of the Environment, because they are interested in Saginaw Bay. One thing we learn, of course, is that larger tributaries like the Saginaw River deliver more phosphorus. Small ones, not so much. If you see those asterisks up there, those are direct rivers to the bay. Without asterisks, they actually feed the Saginaw River. So there's not big news there. The big news comes in when we take the loading amounts, so it's total phosphorus load, tons per year, divide it by the area of the drainage, so the subwatershed. So if I go back to the map and grab that star right there and have a program tell me what land drains into that point, it'll show me and give me an area. And so I divide that by the area, and then things start to stand out. We can't do anything about loading that's driven by the amount of water that moves. We can't shut the Saginaw River off. But if something has a higher concentration, that means something's adding to that source. And so when loading per area gets high, like it is here for the Flint River and the Shiawassee River, something else is going on. And oddly enough, surprisingly, the 2 years that we measured, farm country wasn't contributing high phosphorus loading per unit area. It was the more urban watersheds and the point sources. So wastewater treatment plants are pretty big up in the Flint River compared to the river flow. If we get a wetter year, that was a pretty dry year, in wet years, non-point source pollution should go up. Yep, this year. So there's more water to wash this stuff off the land, so we expect that would go up. And point sources get diluted, so they're not going to change in their load, but they're going to get diluted. So we might see a big shift on this plot in a wet year. That's what we expect. I had a mentor that told me once, we get what we inspect, not what we expect. So we'll have to wait and see what the measurements tell us. I love that saying. You had to be there. So with this data, we're going to figure out what should be done for reducing phosphorus and where we can do it. So we might see that this is the watershed we want to work in. What can be done? Are there groups there that can help us with it? And that's what the Area of Concern program is going to try. Even though it's outside the Saginaw River, it affects the Saginaw River. So I mentioned the invasive species. I'm not going to go into those because I don't research them directly. This is a picture of zebra mussels, some samples that I have. But they do affect a lot of the beneficial use impairments. I had a conference at Saginaw Valley 5 or 6 years ago where I invited a bunch of scientists in different topics, and we had one on invasive species. And everybody in that session, their opinions matched that invasive species are the single biggest threat to the Great Lakes ecosystem because of the food chain disruptions. And I think their point of view was really for fish populations and things like that, but I see where it reaches outside of that. And invasive species are tough to deal with, and usually once they get here, management is what we have to work on. We can't, it's a big task to remove them. So I'll cover one last BUI, and this one's really beach closings is the main one here, but these are three that are related to human and animal waste. So we have to deal with waste, and so I have a picture of students on the beach here taking samples. So historically, we had combined sewer overflows, and what municipalities would do is they would combine the storm water and the sewer water. The goal was to get it away from people, get it out of the streets. Everybody says they want to live back in the 1800s. I don't know, if you go to the cities back then, I think you'd tiptoe through the streets a little bit. You'd wish for rubber boots that weren't available. So the goal was to get it away from people, but they would release it somewhere. So these got released into water, and what really, the big problem was when excess rain would come in and wash these things out, and you'd have raw sewage in the river. So I think this was brought up in the news article that I was sent that you read. And so I remember as a kid hearing on the news, News 5, that, there's raw sewage in the river, avoid contact. Boaters are advised out of the river because of raw sewage, and it's right after a big rain. So that would happen regularly. So what's the problem? Well, nobody wants to swim and poop, right? That's pretty obvious what the problem is. The medical problem is if you ingest it, you can get gastrointestinal illnesses. And not even drinking the water, maybe touching it. Then later on, you didn't wash your hands good enough and you eat a sandwich or whatever, or kids, they chew on their fingers. And so the gastrointestinal illnesses were an issue. The Clean Water Act of '72 put regulatory pressure to correct combined sewer overflows, and wastewater treatment plants were upgraded in the 80s and 90s to reflect that. And so about the same time they were fixing their phosphorus issues, they were also fixing these. Wastewater treatment plants, I've said a few things about them already, but they're really big protectors of the environment. The stuff they take in, the waste, the sewage, I've been to them and I've looked at the pumps where they receive the water from the cities. It's nasty stuff and it stinks. You go home and take a shower right away. Just from being there, they clean out the water. What they put back in the river is good water. And so they're very important in protecting the environment. And especially after these upgrades. And so now, at this time, we don't get untreated sewage in the rivers. You may hear a news article that there's been a combined sewage overflow, and there are some combined systems, but they treat the sewage. And so they'll say there's partially treated sewage in the water. Partially treated means it has been disinfected. So there aren't live microorganisms that can make you sick. So it's much, much better. Back to the BUIs though, there's still some beach closings. They're closing Bay City State Park Beach and others in the area. I think there's a few boat ramps that get checked too. Is this my 10-minute? All right. So we're still closing beaches, and why are they there? Well, what they monitor is fecal coliform bacteria, so evidence of waste. E. coli is the specific one they look for. It's the indicator of the waste. It's not actually the problem, even though some of those can be pathogenic. It's the fact that it's potentially human waste or animal waste that can contain other pathogens, including a few strains of that would be pathogenic. So warm-blooded birds and mammals are going to have E. coli, and so if their waste gets in the water, there will be E. coli numbers. It's going to indicate sewer, manure, or septic overflow problems, and so we still have some of those problems. Faulty septic systems. There are old houses where they have a septic tank and then the drain field just sends the water out to the nearest creek. Aging sewer infrastructure. Just because your city may have the right setup for wastewater treatment, all the old sewer pipes through the city, they're old, they crack. And there have been cases in other cities where they've found cracked sewage lines that were right next to water intake lines, and it's just, so you have to watch for things like that. Not here, of course, but that we found. Animal manure. So there's large.
Water. I think they can go to the I don't think we're going to have that. So, outdoor in the Edmonds area, where the canal comes up, you can see here. As I mentioned, an area inside for alternate displays and then some social laboratory. We'll be able to bring water into the river and do some things in the laboratory on river water. That is into in non-controlled environment. Breaking down spring 27, completed spring or summer 28.
Thanks.
At my age, I have lived with the best water in the world coming out of the Lake Huron.